2 and 1. So welcome to this video on equation of a right bisector. So if you're given a line segment in the Cartesian plane on the xy axis, so I've just plotted one right there for you, and you wanted to find what the right bisector is. Now it's interesting because what is a right bisector? Well, so let's try to find out in this particular video, and I'm going to show you the steps to do it. So here are the actual steps. So here is our line segment that we're going to be working on. And in order to find the right bisector, we are basically looking for a perpendicular line which cuts the line segment, as you can see it, in half. That's what we want to be able to do. If you want to be able to cut it in half, then you know you're going to have to find the midpoint of the line segment. So that's one of the things we'll try to do. And if you want to be able to find perpendicularly cut in half, then we're going to need to know what the slope is of the line segment, and then we can find the perpendicular component, right? Or just simply invert the slope and then take the negative, and that is because of perpendicular lines. And once you do that, you can find an equation of a line. Okay, so let's take a look and see those steps in action. So my first step is going to be, now it doesn't really matter if you actually start with step 1 or if you start with step number 3. So finding the slope or finding the midpoint, you're going to have to do either or, so it doesn't really matter. I'll start with the slope. So if I have this particular line and I wanted to find the slope of this line, and I would do that, so simply y2 minus y1, so rise over run, and x2 minus x1. Doesn't matter which one will be point number 1, point number 2. So I'm going to take, let's say, this one, so point 2, and make this one point number 1. So if I do that, then I'm going to have, so this is going to be 2 minus negative 5 all over. And x2 is going to be 5 minus, and this is going to be negative 4. So that's going to be 7 over 9, and that is your slope. Now, once we have this particular slope, we're going to need the perpendicular component of it. So notice right here, so I just said that's going to be your step number 2. Going to have to find what the perpendicular component of that is. Now, you may or may not remember parallel and perpendicular lines, kind of from grade 9. If you like, you can have quite a few examples. I'll put up a link up above. Now, if you remember that component, then you know that all you need, if you want to find the slope that is perpendicular, is just simply take the inverse right here and take the negative of it. So if I take the inverse of this, it's going to be 9 over 7, or simply take the reciprocal, all right? So not the inverse, I guess I have to be careful. So it is the reciprocal, and then I'm going to make it negative. So that's going to be my slope, all right, of my right bisector. Now, bisector means we're going to have to cut this line segment in half. So we're going to be doing that next. Now, if I want to cut it in half, then I'm going to have to find and go to step number 3 and find the midpoint. Well, so finding the midpoint is not a huge problem. So we can certainly do that. So that's going to be, I'm going to cut this up and make a triangle here. So right angle triangle. And I'm going to try to find the midpoints of both the x and the y so that I know exactly where my midpoint would be. And again, so I have done videos on midpoints. Okay, I'll put up a link up above if you want to see more examples of that. So for our midpoint, so I'm going to take the x first. All right, so for my x component, so this is my component of x of my midpoint. So that is going to be, so 5 plus negative 4. So it's going to be 5 plus negative 4. So what you're doing is, again, for midpoint, okay, so you're going to take the x components, you're going to add them together, and then you're going to divide it by 2. So you're basically taking the average of these. So that's your x component. So this is going to be a half, 1 over 2. Change it to decimal if you like. And then for your y component, so again, you're going to take your y components now. So this one and that one's just going to be -5 plus 2. And again, you're taking the average of it divided by 2. So this is going to be -3/2 or simply -1/5. So now let's check if that is really the midpoint. So 0.5 and -1.5. So 0.5, so that's going to be right here. And then -1.5, which indeed, all right, so is right there. So here's our midpoint. So this is what it would have been. And this is what it would have been right here on the y. So that's our midpoint. So now we have a point in the middle, which is, I'll keep it as 1/2 and -3/2. So now we have a point and we have slope. So we can certainly find the equation of the line of that right bisector. And how it will look like, I'm going to just change, highlight it within here. So the way that it will look like, it's going to be perpendicular here. So it's going to go and cut it, okay, in this particular way. And of course, it's going to have a 90-degree angle between it, all right, and the line segment. So that is the right bisector. So let's calculate it now. So I know a point and I know the slope. The slope is -9/7. I'm going to find my b, which is my y-intercept right here, by substituting the point. So here's my x and the y value that I have, which is -1.5. And all right, so let's keep it. I'm going to change this up here. I'll just keep it in fractions just to be consistent. So we have that. And that's going to be, so this is -9/14 plus b, -3/2. Let's bring this one over on the other side. It's going to be -3/2 plus 9/14 is equal to b. You can find a common denominator between these two. It can be 14 in here. So it's going to be -21. So we have that. And -21 plus 9. So this is going to be, I guess, what is that? 12/14 is equal to b. So reducing it by 2, so this is -6/7b. So our equation of the right bisector is going to be 9/7x and -6/7. And there you have it. That's how you find the right bisector of a line segment.